In this video, we basically want to prove two identities. It says use trigonometric identities to show that tangent of 3x is equal to this expression, and cotangent x plus cosecant squared, well, cotangent squared x plus cosecant squared x is equal to 1 plus cotangent squared of x. And we're going to use some identities. We have one here. We're going to use Pythagorean identities. 1 plus cotangent squared theta equals cosecant squared theta. Tangent of a sum of two angles breaks down, expands into this. And this, of course, is using the sine of a sum of two angles and the cosine of the sum of two angles, because tangent can be broken up into sine over cosine. And then, of course, once you have this identity, you can easily prove this one here with a and b both equal to theta. This would be tangent theta gives me 2 tangent theta, and tangent theta times tangent theta is tangent squared. So you can prove this one here, or you can prove this one using the tangent of a plus b. Anyway, these are the ones we're going to be using. Here we'll show that the left side is equal to the right side. And we'll start with number 2. This is the easier one. We have cotangent squared of x plus cosecant squared of x is equal to 1 plus 2 cotangent squared of x. So we know we have to have at least one cotangent squared on the right side. We have it right there. We don't have a cosecant squared on the right side, so that's the one we have to get rid of. So let's just do this. Cotangent squared x. And from the identity I just showed you here, we know that cosecant squared is 1 plus cotangent squared x. Instead of theta, we're using x here. So now we just combine. We have cotangent squared x, cotangent squared s. We have a 1 right there. So we put 1 plus the 1 cotangent squared x plus 1 cotangent squared x is 2 cotangent squared of x. And there you have it. So that one's pretty straightforward. Just making substitutions for cotangent squared of x. And we got the result we wanted. Okay, for the first one then, we have tangent of 3x is equal to. So notice on the right side, we don't have a 3x, it's just x. So we have to reduce this from 3x down to 1. So we'll start by doing this. So we have the tangent of 3x can be written as 2x plus x. So tangent of 2x plus x is the same thing as tangent of 3x, because 2x and x is 3x. Now we can write this using the identity we just went through. When you have the tangent of a sum, instead of a and b here, it's just 2x and x. Those are 2x is the a and x is the b. And it said it was the tangent, whatever you put for here, so that would be 2x plus the tangent of x. And then the denominator is 1 minus the tangent of a. In this case, our a is 2x here, times the tangent of b. In our case, b is x. So we've gone from 3x, now we have a 2x and an x. So the tangent of x is okay on the numerator and the denominator. Now we use the identity for the tangent of 2x. So that was equal to 4. So all I'm going to do is use the identity with a tangent of twice an angle. So in this case, 2 tangent of x over 1 minus tangent squared of x. So tangent of 2x gets to be replaced by 2 tangent of x over 1 minus tangent squared of x. And there's this still plus here, so I have the tangent of x on the right side here. In the denominator, I got 1 minus tangent of 2x there. Gets replaced by the same thing. So this is 2 tangent of 2x, and this 1 minus. This is tangent here squared of x, and this is just an x here. And then I've got the tangent of x multiplying here. And now it's just a matter of simplifying this. So it's a complex trig expression here, fraction. So I'm going to multiply the numerator by 1 minus tangent squared x. It's a complex expression here, complex fraction. So this will get rid of the fraction in the numerator and the denominator. And this is a square here. So all I'm doing is multiplying the numerator and denominator by the common denominator, which is 1 minus tangent squared of x. So with the numerator, when I multiply the numerator by 1 minus tangent squared of x, it's going to cancel this one right here. And it's going to multiply the 2 tangent of x. So it'll be 2 tangent of x, cancels it there, 2 tangent of x, and then it multiplies the tangent of x, so this will be plus tangent of x, multiplying here. So tangent of x times 1 minus tangent squared of x. Tangent times the tangent here will give me a cube. This will be minus tangent cube of x. And that's what you have there. This cancels out, leaves me the 2 tangent of x, and then tangent of x times expression tangent of x times 1 tangent of x, and then tangent of x times the tangent squared. It's minus tangent cubed here. And then the denominator, same sort of thing. This is going to cancel here. The 1 minus tangent squared will cancel. So I just have 1 times that. So it'll be 1 minus tangent squared of x times this one here. Now when I multiply this second term in the denominator, again this denominator is going to cancel. It's just leave me a minus 2 tangent of x. But then I got a tangent of x. Okay, I need the x here. It's going to be minus 2 tangent squared. So minus 2 tangent squared of x. So again, 1 minus tangent squared of x times the 1 gives me this right here. And then for the second term, the 1 minus tangent squared cancels, leaves me with minus 2 tangent, and then times tangent, I get the minus 2 tangent squared. And then this is going to equal to 2 tangent of x, and the numerator 2 tangent of x plus tangent of x is 3 tangent of x. And I got the minus tangent cube of x. And the denominator, I just have the 1 here, minus tangent squared of x, and then minus 2 tangent squared of x is here minus 3 tangent squared of x. And that's what we wanted to show. I wanted to show that tangent of 3x equals 3 tangent of x minus tangent cube of x over 1 minus 3 tangent squared of x, a trig identity. And if you're planning on taking calculus later on, you'll see quite a few of identities, especially when you get into integration. Thanks for watching. We'll see you next time.